My name is Mason London. I'm a graduate student at Humboldt State University. I'm going to be talking about intermittent streams, but when there's water flowing in them. I'm going to be talking about the impacts of stream intermittency on benthic macroinvertebrates in the Mattole River headwaters. So first, to clarify what an intermittent stream is in comparison to a perennial stream. So perennial streams have flowing water all year round. Intermittent streams have regularly occurring dry periods. And like Matt said, ephemeral streams are generally always dry, yet they do experience some wetting during large rain events. All of this in a natural setting is due to a lower water table. Climate change predictions expect more perennial streams to become intermittent due to drought and less water recharge in the water table. So it's important to understand the ecology and the functionality of these streams. So this leads to the goal of my project. I wanted to better understand intermittent stream ecology by comparing benthic macroinvertebrate community composition among both perennial and intermittent headwater streams of the Mattole River. The Mattole River is a relatively small watershed. It's about 100 kilometers from the headwaters to the mouth. The mouth lets out just below Cape Mendocino, which is the most western point in the lower 48. The headwaters are unique. Well, this whole area is unique because it's located at a place called the Triple Junction. It's 3 major tectonic plates that meet. So you see a lot of groundwater at different depths in this area. So in this headwaters, which is 20 square kilometers, you have both intermittent and perennial streams. So this is a perfect place to do a study like this. So this is an example of one of my intermittent streams. I took this photo right after a large flood event in March, and then 7 months before, this photo was taken on the same stream system. No surface flow, there are isolated pools, and this guy is counting juvenile coho, which I'm pretty sure didn't make it through the season. So then compare that to one of my perennial streams, the South Fork Bear Creek. Looks similar after that same flood event, and you can see in August it's not a drastic flow, but what makes the perennial streams and the intermittent streams different is that these perennial streams do have surface flow connecting little pools, but the flow is very little. So I collected my fieldwork in June of 2016. I sampled 10 streams, 5 perennial, 5 intermittent. I followed swamp protocol for these collections using the target riffle composite. So within 150 meters, I located 8 riffles, did 1 square foot kick net samples, combined them together for 1 sample. I chose June to do this because it was the longest period in time that these intermittent streams had water in them. I wanted to do this so the 2 stream types could be equalized. I figured I would get a lot of false positives and composition difference if I sampled right after the flow started again in the fall, because the habitats had been so long for so different. So like I said, I followed swamp protocol, and the reason why I did this was to be consistent with other state projects, but also to look at all physical and chemical parameters. I wanted to make sure that these streams were actually similar, and the only thing that was different was one went dry and one kept flowing, which they were. So I collected 80 unique taxa and identified over 11,400 individuals down to the genus level. And this is a lot of data to work with. However, there was only 10 streams. So to start, I ran a non-metric multidimensional scaling ordination plot. And you can kind of see some lumping together, but this isn't really good, and probably it's because I only had a sample size of 10. However, this slight clustering you do see is because only a few taxa showed significant differences. The dicronatas, for example, it's a type of crane fly. They're a lot more tolerant than other species, and they can sustain in isolated pools when the streams go dry. Versus the Optiocervus, which is a riffle beetle, and hence the name riffle beetle. It likes riffles for habitat. So I noticed a lot less of those in the intermittent streams. Also, due to recolonization of taxa, once the intermittent streams started flowing again, these riffle beetles have a hard time recolonizing aerially compared to a caddisfly or a stonefly who can fly farther. So this is interesting and it's cool, but it's not really telling me too much about the ecology of these streams and how they function on a larger scale within the stream system. So what I did next is I broke all of my taxa up into functional feeding groups proportionally. And the functional feeding groups are a great way to assess the functionality of these streams. So based on Van Note's river continuum concept, in the headwater streams, you expect to see a lot of collectors and shredders because that's where a lot of this nutrient material is coming from. All the allochthonous material from leaves and debris enters in these smaller, more steeper headwater channels. Shredders are responsible for the breakdown of this organic matter into finer, more usable organic matter, which is taken up by collectors. So as you move down into higher order streams, third, fourth, fifth order streams, the channels start to open up. You have less allochthonous input, and the composition changes. You see more collectors, more grazers, which I've called scrapers, and so on and so on. So you can see in my streams, the 5 intermittent on the left and the 5 perennial are on the right. It's dominated by gathering collectors, which in the spring is what you would expect to see. There's a lot less leaves in the stream, so shredders aren't as important at this time. So I plotted all of the functional feeding groups binomially. You can see on the bottom of the plots that's intermittent and on the top it's perennial. So the binomial plot, it was 0s for intermittent, 1 for perennial. I ran Welsh's 2-sample t-test for significance and differences, and then I ran general linear models to acquire AIC values. And the only significant functional feeding group present was shredders, with lower proportions found in these intermittent streams. So here's the general linear model of the shredders. And so general linear models are great for gradients and change for habitat suitability. And since a stream is either perennial or intermittent, this might not be the best way to display this, but visually it shows you that there are these significant differences among the two different stream types. So why are shredders important in headwater systems? So as a leaf enters a stream system, it starts to get colonized by microbes, both bacterial and fungal. And the shredders aren't really interested in eating the leaf. They want to get the bacteria and the fungal matter. So the analogy I've heard, which I like, is you're a shredder and you hate crackers, but you love peanut butter, and this leaf in the stream is a peanut butter cracker. So you are going to town and eating all the peanut butter, and in the meantime, you have all of these little crumbs and flakes that drift downstream. So there are nutrients in this leaf that other organisms can use, which leads to this guy who is a filtering collector. So once this leaf matter is suspended, he can then acquire the nutrients that the shredder has freed up from him. There he goes, and he eats it. And then even further downstream, where you see a lot more grazers and shredders, the feces that the filtering collectors and shredders produce are more added nutrients to the stream system, which aid in the growth of primary production. And so you can see all this other material that has been drifted down, and these guys are drifting. So you can see that the shredders are actually like an apex organism that stimulates nutrient spiraling from the headwaters all the way down to larger channels. So the question here is, why are we seeing this lower proportion of shredders in intermittent streams? I saw an average of 7% in the intermittent streams and an average of 18% in the perennial streams. So one study I found that was done in 2009, it was a mesocosm study where they took a stream and isolated flows in one section, so ceased flows, and then added leaf packs. And they found that there was substantially less microbial recruitment when the flows ceased. So one thought is, in the fall, when you have all the deciduous leaves shedding their leaves in the dry channel, you're not having any microbial activity. So then when the flows start up again in late fall and the taxa that are going to recolonize these intermittent streams start to move, there's substantially less food in these intermittent streams. And if that's the case, they might still recolonize, but there's not enough food, so they might not survive, or they might have some kind of triggers to know which streams to go to. I'm not really sure about that part, but that's just one thought. So to summarize, there's a lower proportion of shredders found in intermittent streams than in perennial streams. So with the climate change predictions, like I was mentioning, we're expecting to see more intermittent streams. This could potentially mean that we're going to see less available organic matter being dispersed down into larger stream systems. Further research, though, to test this needs to be done. I would like to implement at some point more sampling in the fall as these streams re-wet. I can then kind of map to see which taxa are recolonizing, and then do consecutive sampling in the spring as the streams run dry to kind of see how these taxa are dispersing. Also a way to quantify the microbial colonization among the leaves and to correlate that with shredder recruitment. I also want to thank Cal SFS for giving me a grant to come here and acknowledge all these other people. Thanks.
We have time for a couple questions.
Yeah.
Did you look at volcanism?
Yeah, so among the few taxa that I mentioned, I think there was like 6 or 7 taxa that showed to be significantly different among the two stream types. For example, there was dragonflies. 4 of my 5 perennial streams had dragonfly larvae, and 0 of my intermittent streams had dragonfly larvae. I know dragonflies live multiple years in their nymph stage, but that's also interesting, but they can also live in stagnant pools, so you think that they could recede, which maybe there's something else there. They're predators, so maybe there's less food in the intermittent streams at the times that they want to feed. So that's something I need to go back and look on more with the specific taxa that showed differences.
I'm curious, did you run the CSCI scores on both sets?
So what I initially did, I'm glad you asked that question. I followed SWRCB protocol, collected way too much data for this project in doing so, because I was thinking if I did see these huge significant differences, I could then run the CSCIs for each of these streams and then kind of determine how they hold up with intermittent perennial streams. I'm not confident that the significance I'm seeing is big enough, so I haven't bothered to go through and run the CSCI, but that is something that I'm interested in doing.